Hello Internet! In this video we are going to be taking a look at debugging Unity and hopefully it's going to be something that you can kind of use to more easily figure out what's going on when things aren't exactly what you thought they should be. So the idea of debugging is sort of to give you a better view into what you're actually doing instead of just writing a bunch of debug log statements in your code. Hopefully that makes sense. What we're going to be doing is we're going to be using Visual Studio Code in order to accomplish that. And specifically, we're going to be using this new extension, I don't think it's new, the Debugger for Unity. And so this extension just can be downloaded and used. I think that's pretty much it. I'm actually going to start more or less from scratch. So we're going to close that and just go. So the first thing I want is just some basic script. So let's do like a test script. And we'll just attach that to our camera, I guess. It doesn't really matter where we put that. We just need it somewhere. And then the idea here, the way debuggers work is unlike with like print lines, which kind of just keep your game running. And so like every update, you might print some new statement out and you'll just keep getting new values. A debugger actually freezes your program and captures the entire state at that point. And so what that allows you to do is actually go in and like modify certain values. So you can actually view what is the position of this object at this point, and things like that. So in this case, let's just do something really basic. Let's just do a public float time and set that equal to something. In the start, we'll set time equal to 0. And then in the update, we'll do time plus equals time delta time. So this is just gonna constantly keep counting up over time, and it should just give us a sort of a way to do this. So the way to start debugging is we're going to need this debugger tab, the thing that looks like it has a bug crossed out, kind of killing those bugs. And so we have no configuration assigned, and if we look at this, there's no configuration at all. And so when you install that debugger extension, you can add a configuration by clicking that add configuration button there. And that's going to give you a whole bunch of options. We want the Unity debugger option. It's down at the bottom here. I have a few other extensions. And so we're getting different things like Docker and Java and things like that. We want to make sure we pick the Unity one, and it's going to bring up all of this stuff. This path here is going to look different, because this is the path to my location. Yours should be different, but everything else should be the same, because all of this is just kind of different configurations for different things. And you can actually go in here and modify certain parts of this, but you probably don't need to. So it's probably not really something that you need to worry about. But this should be fine for what we need, and you can see it's already selected Unity Editor up in the top left here. And so we can actually just start debugging. And what this is going to do is actually attach a debugger. You can see we get this fancy control thing here. And let's add a breakpoint on time plus equals time to delta time. What that's going to do is tell Unity to stop every time it hits this point in code. And so if we come here and run this, we should almost immediately get stopped. And so you can see it's highlighted this line now, and we can actually see by hovering over each of these values what the actual value of that is right now. So the time, since this is the first iteration of this, the time is equal to 0, and the delta time is going to be, I don't know if we can get into that. It's going to be something, but there's a few other things that are going on here. We have local variables. So in this case, we have this, and this is our main camera. It's what we're attached to. And so we can actually look at everything that's going on inside of this and kind of view certain things, like it's tagged as the main camera and has specific transforms. We can actually probably see like the positions and forward vectors and all that fun stuff. So there's a whole bunch of stuff here, and that's sort of the way this works. Another handy thing is this watch panel. That lets you watch things in the scope that your breakpoint happens in. So what we're going to be mostly concerned about right now is the time. So I can just watch the time, and you can see it's going to pull out 0. We should also be able to do something like transform.position, and we can actually pull out the position of our camera as well. And so this is going to be whatever breakpoint we hit, it should pull out the transform position of that object and put it here for us. And so that's just another handy thing to do there. And then the final really fun thing to do is down here, it's the Debug Console. And so this actually lets you modify or run code at this point in time. So the game is paused, everything's frozen, but we can actually change specific things to kind of do that. So we might think we want to do like time equals 10. Did that actually work? Yeah, it did. Okay, cool, that works. I guess that was a bad example because what I was trying to show is if we try to do like transform.position equals new vector 3, and let's just 0 the camera, so put it at 0, 0, 0. It doesn't know how to evaluate this. And part of the problem we're running into here is we're using a vector 3, and vector 3s are actually part of the Unity engine. They're not just part of like C#. So they're not just a basic primitive type that we can just plug in anywhere. We actually need to include these somehow. And so the way to do that is just transform position equals new Unity engine vector 3 0 0 0. And so this is actually the full name. This is actually including the namespace inside of that. And if we hit enter here, it doesn't work. Why not? Okay, this worked, I swear. Okay, I imagine what's going on here. That doesn't make sense though. Okay, I may have screwed this up because I was assuming we should just be able to pull that out. The transform position equals the new Unity engine vector 3. I'm pretty sure I typed that right. So I'm not entirely sure what's going on there. I will double check that and get back to that. But that's kind of hijacking the rest of this, so we're just going to keep going. What we can do now is kind of keep doing things. One thing you might notice is if you go back to Unity, well, you can't, because Unity is paused. So like we have this, and it's trying to run, but it isn't running. And that's because we froze our code. And so while that's there, you're not really going to be able to play your game. Nothing's going to work. And so we can either continue, which is actually going to step over until it hits another breakpoint, which means the next frame. So we can actually just do that. And you'll see the time increased by 0.02. And it actually kind of flashed in the watch panel, so that will actually show you what values updated between each step. And you can kind of do that. There's a few other options here. The step over is going to go to the next instruction in line. So this isn't really going to cover any of that. This is more for like functions, for example. So in this case, if we have, well, actually, let's get into that now. Let's actually write a function and do that. So what I'm going to do is just remove this breakpoint and continue. And Unity should go back to its normal self and just be running normally. And there you go. So everything's working. Our position is still what it was. The time is where it was. Everything's good. And that actually, if I had gone back immediately, we would have seen that the time had actually started at 10 because we had actually adjusted that value. So this gives you sort of a way outside of the inspector to change these values. So what we want to do is actually introduce some functions here. So we can actually play with stepping over, stepping into, and then stepping out of different things. And so the way those functions effectively work is they give you a way to skip over a function. So it will return the results of that function and effectively move in the same line, like a linear path. Step into will actually go into the function and start on the first line of the function call that you're going into. And then step out of is going to go one up the stack. So if we write something like time wrap time, I don't know if this is this is a good idea, but we're gonna wrap the time by 10. And what this is going to do is go through our time. We actually probably want time 10 blah 10.0f. All right, getting confused. Float time float wrap. All right. So what this wrapping of time is going to do is effectively just take a mod of this, and we're just going to effectively wrap the time around so that it never goes around or above the wrap value. So in this case, we're just going to say return time mod wrap. So as this increases up to 10, we should see it kind of wrap around, and it should never break anything. I don't know if that's particularly useful as a function. It doesn't seem that useful, but that's sort of what it is. What we're also going to do is stick a log statement in here, just because it's some like a no-op-y thing that we can kind of use. And so actually, we can do one better. We can actually just say result time equals time mod wrap, and then just return the result time like this. What I'm trying to do is get 2 lines in this function so we can actually do a step over inside of it and a step out of to kind of go into a little bit more about what's going on here. And so that should be good. I'm going to re-add a breakpoint and everything should be good. It's been a little finicky with reattaching. Like you can see, it's still, our debugger is still running, so it should still work. But I've had issues where it doesn't reconnect after every run, but hopefully we won't run into that. And so what I'm expecting is this, where we've hit our breakpoint here. And so this first line is the same. So what we're going to do is we're going to step over this, and that's going to move us to the next line. And so our time has increased, but we haven't exited our update loop, and you can see the highlighted line has changed. What this highlight means, if I wasn't clear before, is this is the line that will execute next. So if we, like the immediate next thing that our program is going to do is going to be that line. And so if we jump into this, we can just step into it, and that's actually going to go into the function, and you can see we actually start on this first line. It's not even on a function yet, it's actually just at the entrance to the function. And so we can actually see what's coming in. So our time is 0.02 and our wrap is 10, but nothing else has happened yet. And so what we can actually do is, if we don't really care, we can just step out of this function, and that should return us back up here. So what that did is executed the entire wrap time function and then returned us to the end of that function. There's nothing behind it. So we ended up here with a time of 0.02. So that's pretty much what those are doing. Stepping over is just going to keep going. And in this case, we actually wrapped around a full cycle because there's nothing else to go out to. Once you exit the stack, it just kind of stops or continues effectively. It's effectively continuing. So that's that. So we can actually just let this run like that. And so Unity is just going to keep going now, and we should just keep having numbers cycle through. What I'm curious to do, though, is, and I haven't tried this, let's try a breakpoint, a conditional breakpoint. And so these are a little bit different than a normal breakpoint. A breakpoint just breaks every single time that gets hit. A conditional breakpoint is going to break when a condition is met. And so one of the handy things is we can actually do like transform form.position.y is greater than 10. So when the y height is greater than 10 or less than 0 or whatever, we can have it break and not break otherwise. You can also use a hit count, for example, which is going to break after like 100 hit times the breakpoint has been called, which might be useful for like if you want to fire 100 bullets and then stop. That's a way to do that relatively easily. I haven't really played with... Oh, a log message. So this is just going to log out a message, it looks like, when that gets hit. I've never really played with those. So here we're just going to do this, and if I add this breakpoint, you can see we have a slightly different icon here. You can't see because my camera is blocking it. There we go. But we actually have a list of all the breakpoints down in the bottom here. And so each of these can be enabled or disabled, and it will enable and disable it in the editor. And if it's disabled, it's never going to get called. But that's just a handy sort of thing. The call stack is less useful. I can show you what that looks like after we hit something. But in order to actually trigger this, we need to get our camera above y equals 10. And so we can just drag that up. And it says 9.95 here, but we hit our breakpoint, which means we must have gone over it. And if we were to do this, you can see our breakpoint says our transform position is y equals 10.01. So we're slightly above that point. So this is sort of all demo stuff, but it gives you a way to actually say, when this happens, break my code and let me actually see what's happening. And this is really useful for like, if things are going horribly wrong at this specific point, like you trigger this door or something, you can put a breakpoint right there and try to get right into what's going on. And this might be the way to do that. So there's a whole bunch of stuff there. I'm not really going to go into a lot of this, but that's all there for you to kind of explore. This call stack is less useful, but what it's going to do is show you the function calls that are above whatever you're doing. So as we actually step into this, I stepped over it. That was a terrible example. There we go. We're back to where we were. We hit our breakpoint again because we didn't move our camera. If we step back into this, you can actually see the call stack gets updated. And so since it's a stack, it's last in, first out, which means that the top thing is the last thing that occurred and is the first thing that's going to get popped off the stack. That's sort of how function calls work. And so the way this is working is our wrap time just got called, and so is now on top of the stack. And so we can actually see that. We can see what line it's on and what script it's existing in. And so if you have like a really long chain of things calling other things, this will actually be really helpful to kind of drill into what's calling what and where. And so that's where that would be useful. I don't actually know what these other threads are from. I think they're just extra stuff. Typically, your main game thread is going to be single threaded, so you're not going to run into this. If you run like the ECS system, which is multi-threaded, I believe, this might be more interesting. But we're not, so it's not. But that's where we are right now. And so that is most of the debugging stuff. Some other things that you can do that should work is we can actually like find game objects. So the what's it called? Game object dot find game object with tag, for example. We can do this down in this debug console. So there's a main camera game object, or there should be. And so we can actually do unity engine dot this. And I'm going to move my camera because it's going to be long, bouncing all over the place. All right. So what this is doing is saying in the Unity engine namespace, use the game object class and call the find game object with tag method with the main camera parameter. And what we're going to do is just set the transform.position equals a new Unity engine vector 3 0 0 0. This should work I ran this exact command previously in a different thing. So if this doesn't work, oops. Oops. Okay. I guess all the best examples don't work. What am I doing wrong here? Because that should work. Dot transform dot position. Huh. Okay. Well, no, it's not that. I don't know. We'll have to do a different video on this. That was working. I was pretty sure it was working. It's not now. So, yeah. Not really sure. Oh, hold on. I know what's going on. I'm gonna say that, and it's not gonna be what's going on. But we need Unity Engine at the front here. Okay, no idea what's going on. It's broken. Anyway, that failed, but everything else worked. So we're gonna leave it there. And you can't run a debugger on the debugger, so I'm not gonna try. But hopefully the rest of this is something that you can use in your projects, and it's something that actually helps you get to some of those more nasty errors that you run into. And I'll do some more digging into this debug console, because those, maybe I'm typing it wrong, maybe somebody knows what I'm doing wrong. I probably know what I'm doing wrong, I'm just not looking at it right. But I haven't been able to figure that out this video, so we're just going to ignore it. Most of this stuff, though, is a lot of the stuff that you're going to want. This debug console is more a la carte, I guess. It's more of that like really handy, hacky stuff, I guess, when like everything's failing and you're just like, ooh, let's just inject this, or destroy this, or try this. That works, but you have Unity, so for the most part, you can kind of ignore a lot of that stuff. But yeah, that's most of this. So hopefully that's enough to kind of get you started working and using this. And if not, let me know and we can take another look. But yeah, that's it for this video. So until next time, see you, Internet.